So in this video, I'm going to discuss about the stepped bar with the number of loads acting on it. Okay, if you see this, two portions are there. It's a stepped bar, two portions. Okay, then here in this problem, three forces are acting: 30, 10 and 20. So already we solved the problems. It is on the single force acting on the stepped bar. But right now here, if I use the equation formula for this sigma is equal to force by the area. So here the diameter is mentioned for both the portions. But what about the force? We don't know the force. There are three forces are there. Which force we have to consider? The important step is the finding out the force which is acting on the each portion. So that we have to calculate, and there are some of the steps are there that it include. We will go through it one by one. Okay, first in this problem, first we will find out the area. So area is the circular A1. So first we will divide this into the portions. So take here as A, B and C. So you can number it as 1 and here it is 2. Instead of taking that, better you take A, B, B, C. So here I will write here area of AB is equal to, so it's a circular one, pi d square by 4. So it is pi 30 square by 4. So answer is 706.85 mm square. Okay, second, area of BC. Area of BC, same equation, same formula, pi d square by 4. So substituting, instead of 30, we will substitute here as 20 square by 4. So answer is 314.15. It is mm square. So next step. So we already calculated the force. Area. We need to find out what is the force. In the number of force acting on the member. So first we will consider, right here, consider portion. This is AB. Portion AB. I will draw the figure of this. Here it is AB. So diameter 30, length is 500 mm. Okay, first step, to identify what the magnitude of force acting on the portion AB, first step is that we have to draw one section in between this portion. So section we have to draw like this. This is a section. First you have to draw a section in the middle of the portion AB. Then check on the right side, okay, and then left side. Check the right side as well as left side. So right side, how many forces are acting, and left side, how many forces are acting. So if I draw the figure here, the same manner. So there are two forces are acting on the right side of that. It is 10 and 20. There are two forces are acting on the right side. And here on the section left side we have only one force is acting, that is 30 kilonewton. So I will write here as 1. Right side is 2 and left side is 1. And then after identifying the number of forces, you have to give a sign convention. Sign convention. So we have to assume or take a sign for a tensile force. For a tensile force, take the sign as positive. For the compressive, take the sign as negative. Very important thing. Just remember, this is always fixed. This sign convention will not be changed. Tensile as positive and compressive as negative. So if I take example, if it is 10 kilonewton is acting on the AB portion, what it will do, whether it will elongate the portion or whether it is contract the portion. No, 10 kilonewton is acting away from the portion. Definitely it is a tensile force. So I will take that as 10 plus 10 kilonewton. And same manner, if I take the 20 is, so first 20 is also, it is acting away from the cross section, and then it is a tensile one. Just remember that while we are considering a force, while we are considering any force, we will remove these two. If I taking the 10 kilonewton, so we will neglect that 30 as well as 20. 30 as well as 20, just only to identify whether it is a tensile or compressive. So I will take 10, eliminate 30 and 20, then I will check whether it is a tensile or compressive. So I identify that it is a tensile. Same manner, while I am working on the 20 kilonewton, I will eliminate 30 as well as 10. Then what will happen to this? It will elongate. This force will elongate the cross-sectional area. Means here on the AB, right side of the AB portion, right side of the section, these two forces are positive. These two forces are positive. I will write here as first force plus 10 and then here as 20. It's a kilonewton. Okay. Then check it on the right side, sorry, left side. Again, what will happen? It is acting away from the cross section. So definitely it is a tensile one. So here it is plus 30 kilonewton. So I will make the summation of these two. So I will get here as 30 kilonewton. So you understand that the forces, the summation of the forces on the right side will be equal to the summation of the forces on the left side. Means if there any problem is happen, if the values are not similar on the both the side, it can be concluded that there is something we made a wrong or a mistake in the calculation part. So right now here, just remember always, after taking a section, identify the forces and then check whether the forces are tensile or compressive, and then make an addition of that, or if it is a compressive, you can make a subtraction of that. It depending upon the sign, whether it is a compressive or whether it is a tensile. In some problems, what will happen, instead of giving a compressive tensile, they will give a compressive forces. In that case, there is a contraction. But right now, we are not discussing about the contraction. There is these forces will give a tensile and the elongation. So the force acting on the AB portion is 30 kilonewton. So I will write here as sigma AB is equal to force by the area. The force is 30 into 10 raised to 3 divided by area is 706.85. So answer is 42.44 MPa, or it may be Newton per mm square. Next is delta LAB. Here also in this problem, you need to find out what is the total elongation. Okay, total elongation. Delta LAB. So I will take the same formula, FL by AE, substitute all the values. Force is 30 into 10 raised to 3 into length is given as 500 divided by the area 706.85 into Young's modulus. We assume that it is made up of steel and it is 2 into 10 raised to 5. Answer is, it is 0.106 mm. This is a way how we are calculating the stress as well as elongation by using the force. So next I will consider the portion BC. I will draw the figure of that. BC, we have the diameter as how much it is, 20, and then length is 600. Okay, then first step is draw one section in the middle of the portion. It is a section middle of the portion, and check the right side as well as the left side. How many forces are acting? I will draw one line here, section. So right side is only one force is acting, and left side we have two forces, that is 10 as well as 30. So we will check the nature of the forces. First I am going to consider 20, neglecting the 10 and 30. So what it will do? It will do the elongation. Okay, it is because it is acting away from the cross section. So here I will write only one force plus 20, tensile as positive. Okay, next on the left side two forces are there. Okay, first I will consider the 30 kilonewton and neglecting the 10 and 20. What it is doing? It will elongate. It will increase the length like this, so that it is plus 30 kilonewton. So what about the 10? 10 is acting in the reverse direction of 30. 30 means tensile, 30 is a tensile force, then definitely it is acting opposite to that. 10 will be taken as compressive force, or else this force is acting on the cross section. It is not away from the cross section, it is acting on the cross section. This 10 will be a compressive force. It is like this. You have to represent with the arrow. Reverse of the arrow mark will be reverse of the 30, and right here as minus 10 kilonewton. And if I make the addition of this, I will get 20 kilonewton of force. Here it is 20 kilonewton. Right side is 20, left side is also 20. Means summation of the forces on the right side will be equal to summation of the forces on the left side. So means 20 kilonewton will be acting on the BC portion. That's it. So we will continue with this. Consider portion BC. So sigma BC is equal to force by area. Force is 20, 10 raised to 3 divided by the area is 314.15. So answer is 63.66 MPa. Next is delta L BC. Same formula, substitute the values. 20, 10 raised to 3 into length is given as 600 divided by the area is 314.15 into E is 2 into 10 raised to 5. So answer is 0.19 mm. Okay, so stress value is 63 and change in the length is 0.19. So that way to calculate, what we are going to calculate is here, it is total elongation. Total elongation is summation of these two elongation, that is delta L AB plus delta L BC. Both are tensile, means both are positive, increase in the length. So therefore after addition we will have a value of 0.296 mm. 6 mm. In this problem, very important step is to identify the forces, these two forces. Remaining things will be as it is same. There is no change in the procedure or no change in the equations or formulas.